Welcome back, everybody. We are ready to resume. Okay. Our next speaker will be Venkatesh Kannan from iCheck, and he is the Center Technical Manager, Platforms and Technologies Program Manager in the IRIS Center for High-End Computing, also known as iCheck. Thank you, Venkatesh, for being here. It's a very pleasure to give you the floor. Thanks a lot.
Thank you, Daniel. I'll just take a moment to share my screen. Okay, could you confirm if you can see my screen all right?
Yes, we can see it.
Thank you very much. So good afternoon, everyone, and thanks very much for this opportunity to share some of the work that's happening not just at iCheck, but also at a national level in Ireland. So since probably this is, we have a lot of speakers in the past I saw today who covered a wide range of topics. So most recently, JP shared the range of activities happening in France, but also the technical depth in terms of tensor network-based approach. It was very interesting to see the breadth of work that's happening. So I would like actually to take this opportunity as maybe the first in a series, as Daniel has been very industrious in continuing this engagement, this conference, this workshop, so to say. So I'd like to take this as maybe one of the first instances in which we are presenting what's happening in iCheck in Ireland. So I'll keep it not too technically deep. To a certain level, I'll present the technical details, but in a broader sense, maybe give a notion of what's happening in the Irish ecosystem and where we are actually headed to synergize our national efforts in terms of quantum computing and its positioning. So in that respect, so a quick note on iCheck, as Daniel pointed out, we function as the National Center for providing high-performance computing platform and expertise capabilities at a national level by mandate from the government. So we engage with the academic researchers, the enterprises, and also public sector in their requirements for computational and data platforms, and also support them developing and deploying their solutions on these platforms, whether they are national platforms or on-prem or cloud platforms. And in that sense, the quantum computing part comes in because we've always had a tradition of looking at emerging technologies. So 8 years, 10 years ago, it was general purpose GPU computing, and then it became a lot more mainstream thanks to both the hardware, but also the algorithmics, such as neural network based approaches that kind of brought them more mainstream, just beyond visualization and graphic processing use cases. So we have a tradition of looking at these emerging technologies and bringing them into mainstream national service. And quantum computing is naturally one such. It's one of the stronger emerging technologies, alternate computing models that we see. And naturally, the focus there is at a national level to drive the adoption of quantum computing, to evaluate it, track the monitoring of the progression of the technology, and then enable its adoption both in the scientific and research and enterprise communities. So the focus pretty much of the Quantum Programming Ireland initiative, which has been around since mid-2018, is it brings together industry, academia, and public sectors, and iCheck kind of drives and tries to synergize all of the efforts, and with focusing on the positioning of quantum computing and simulation systems alongside HPC systems. And naturally then looking at the software and algorithmics research that can potentially be done at the current TRL levels on these kind of platforms, and then feeding both of the first into national skills development programs around quantum computing and programming. So we are very conscious of learning from the classical HPC experience that we have had in developing a national skill force. So there was a huge surge in data science and machine learning and AI skill sets in the market 3 years ago, and the government and agencies and iCheck, for example, we rushed together to put in place different forms of skills development program, because it's just not about creating master's or PhD degrees, but being able to address a comprehensive workforce development program. And so we take that learning into engaging the community in skills development in quantum computing and programming from a very early stage. So skills development is a very significant aspect. And all of these are funded by a combination of projects and programs at national and EU levels. So a quick outline of the Quantum Programming Ireland initiative. The first is basically, as I mentioned, the requirements of developing and deploying hybrid systems. And naturally, it started with us in developing a quantum learning platform at a national level. So this is, in the first phase, it's not a quantum mechanical device, it's a software emulated device, which we have been putting in place since mid-2019. And COVID has delayed stuff, but we are bringing it as a part of our national service to the users from 2022 Q1 onwards. So this would allow a portfolio of quantum programming and software development toolkits, which can be used for both education purposes, skills development purposes, as well as by the research community. And naturally, the HPC-QS project that JP mentioned most recently in the last talk, but also possibly touched on more by Crystal going forward. That's a project in which Ireland is engaged through iCheck. And one of the parts of the project is to use the Phoenix interface infrastructure to connect, so to say, the quantum learning platform for users to migrate from the national platform to eventually, when the twin pilot systems are deployed, to provide a seamless transition in the environment. But then the journey for iCheck in terms of quantum computing started with the algorithmics. It was the smaller step that we could take with minimum investment. So to say, back then in 2018, 2017, it was to look at the algorithmics and software development, and primarily, naturally, the usual suspects. We started with systems that were more congenial in terms of scientific systems, molecular systems, machine learning, and optimization problems. So we are engaged in both quantum flagship EuroHPC, but also national projects with industry and academic partners. And then from there, it progressed to looking at the software stack as a whole, and looking at how, so to say, QPU awareness can be brought in the classical programming toolkits, particularly parallel programming toolkits that are primarily associated with HPC systems, and Quantex. So Quantex is basically an exascale targeted tensor network simulation framework, which has been under development since PRACE 6IP WP8. So currently we are testing them on some of the petascale systems that are coming up. And that is done in partnership with Luigi and team at LRZ as well. So iCheck and LRZ work together on developing the Quantex framework, and it's being developed as a package within Julia YAO module. So we'll be disseminating more about this by the end of PRACE next year as well. And thirdly, as I mentioned, the skills development program. Currently, we work in conjunction with national agencies in skills development, and are creating a portfolio of, so to say, training programs that complement and also bridge the gap to the more academic research deep dive programs that are available in higher education institutes at a national level. So this also works in conjunction with EuroCC. So going forward a bit more, this is where iCheck was trying to drive the capabilities and skills development and some of the, at least, R&D programs within Ireland. But what we saw increasingly was Ireland as a whole has a tradition of scientists, engineers, as well as programmers who started working on quantum systems. So the Tyndall National Institute, for example, has a tradition of working on photonics and and even ion-based quantum mechanical and device manufacturing. And there are a few other spin-offs from the University College in Dublin and other institutes where people work on semiconductor-based quantum device engineering and manufacturing and the science and physics behind it. And naturally, iChEX, we focus on hardware upwards. And there are a number of enterprise and academic researchers who focus also on the algorithmics in terms of error correction, cryptography, and QKD, and the application areas as well. So we saw that this is going to be important to bridge the community at a national level by bringing together these end-to-end capabilities at a national level. So the High Choir is basically an initiative that is due to kick off soon, and it is meant to be a hub of excellence within the Irish island. And I say island because Northern Ireland is also targeted here to bridge the communities there. So a hub of excellence in the island of Ireland to develop the research activities and systems and applications for hybrid HPC and quantum computing simulation systems. So at a very high level, the focus areas are around eventually leading to creation of a testbed platform that is essential for researchers and students from academia and the user community to independently and collaboratively work on R&D and experimentation and skills development. Then all of this requires naturally a very strong scientific and fundamental research and innovation activity that addresses throughout the stack, the hardware, system, software, the programming environment, hybrid application workflows as well. So this is the core area where we expect most of the work to happen. And then we also realize that this kind of a problem clearly engages experts from a wide range of backgrounds, people with physics background, with semiconductor background, with engineering, device engineering background, both from the quantum mechanical side and the classical computing side. And then we naturally have the HPC community, and then we have the algorithmics communities, domain experts, both students at different levels of expertise. So we saw that it's going to be really important to not just have the communities work on their individual expertise areas, but actually have this cross-domain skill set being built across the community. A very simple example is anyone working on modeling molecular systems in quantum computers. We realized very quickly that we need people with molecular systems and chemistry background, with quantum algorithmics background, programming background, DevOps, and so on. So, and it's always a blended team we end up with. So we saw that there is a significant need and opportunity to kind of twin the researchers and students from across the community, so that 5 years down the line, 10 years down the line, we'll have people with these blended skills more apparent. And naturally, we see this as in the emerging program that is being planned of EuroQCS. We see this is going to be the pathway that will kind of ease Ireland's participation and contribution in the EuroQCS activities in a complete level. And community enablement. Now, this is not probably entirely technical, but what we see is, at least at the national level, quantum computing, the overpromise of quantum computing, what QC can do, is sometimes scary for us. So the messages are promising in engaging the community, but we see that it's really important for both the government, the researchers, as well as the general population to be aware of where quantum computing as a technology is currently and where it is headed, and not follow the hype, so to say. So a continuous enablement of the community's knowledge building is something that High Choir targets as well. So this is where the program, the Hub of Excellence, is going to function the space, and then it's envisioned that this will start in 2022 going forward and bring the complete capabilities from Ireland together under a single umbrella. A bit more details. So the establishment is targeted through national seeding in 2022 starting, and this will formalize, so to say, the ecosystem and serve as the precursor. Naturally, the progression there is then to start looking at partnership and engagement more formal engagement with European programs. So currently there are a number of projects in which the partners of Highquire are engaged. So iCheck, for example, in HPC QS and a couple of Horizon 2020 projects. Tyndall naturally participates in a number of quantum engineering related programs as well. But then in a formal sense, what we aim to establish is across member states a direct collaborative channel and take advantage of activities such as the multi-country projects and others that are emerging through the Digital Compass program going forward, that the European Commission strongly believes will benefit direct member state to member state engagement as well. And finally, what we want to see is basically a sustained end-to-end activity within Ireland, which is strong engagement in Europe and global engagement. So that's where we see Highquire going over the next 5 to 10 years timeline. But this is under plan and progression already. Very quick, so I probably don't need to make the case for this, but all of this started, meaning the hybrid. Why focus specifically on hybrid HPC and QC started with the current ecosystem that we had to face in terms of when we demonstrate or teach or do our own research with the currently available quantum computing systems and software stack. So we noticed very apparently, very quickly that the QC applications or the QC systems naturally reside mostly in a sandboxed environment, in a closed environment by themselves. There are naturally efforts on integrating that at different levels of coupling degrees, either loosely or weakly or strongly, irrespective of it. They still remain currently at large as isolated systems. That's not the worst part. We might be using Python for programming, but for two reasons. Python may be not the most HPC-friendly performant programming language, but also the libraries and tool suites, they kind of still remain quite disconnected from the usual HPC programming models that we have so fine-tuned, and also the data management software that we are so much tuning going forward. So what we see is there is going to be an increasing need to synergize and connect the languages and toolkits that are focused on the quantum computing and programming landscape and bridge them to the classical HPC programming model, and also that applies to the system software level, for example, to schedulers and performance monitoring frameworks to be aware of QC systems and QPUs, so that eventually where we want to go is have different degrees of different models of coupling QC or QPUs with classical processing units and systems. So at the bottom layer, we probably are looking at deploying quantum computing systems as, so to say, nodes of larger clusters that may be on-prem co-location. And then there would also be naturally a federated remote access. But then potentially there are also works that we have at a national level and definitely broader international level where co-location of QPUs and classical processing units on a single die or a single chip is also being investigated. So we see that there are going to be at least a few different modes of integration of quantum computing and programming systems happening at a hardware level and the interconnect around it. Naturally, on top of that, the system software and programming environments need to be bridged so that we can eventually have within a single streamlined application workflow, have, so to say, library calls that are more seamless and latency aware that leverage these underlying integrated software environment. That's where we are headed. A bit more in detail, in Highquire, what's happening is we naturally start, we look at this from a co-design perspective, and what we mean by that is we start at the use cases level. So typically we are used to looking at quantum computing use cases where it's optimization or looking at molecular systems and physics systems, and pretty much done in isolation. What we want to push for going forward is to look at application workflows where it's just not mapping a kernel to a quantum computing programming model, but actually taking a larger HPC demanding workflow and offloading a part of the kernel to quantum computing and then feed it back basically to the classical one. So we are indeed looking at workflows, for example, in physics systems where the diagonalization or post-processing is suitable for classical HPC, and then there is a part of naturally the simulation that is offloaded to the QC. For example, in larger chemical systems, we work on a project where we look at really large chains of CF carbon-fluorine bonds under a category of molecules called per or polyfluoroalkyl substances. They are a class of environmental pollutants. And what we see is it's a systematic chain, a really large molecule. So definitely it's not going to fit under the NISQ factor of NISQ scale of devices. But then the molecular fragmentation, the chemistry community believes that we can have a systematic way of fragmenting or breaking down the larger molecular system into subsystems and then offload the subsystems in an iterative fashion onto a quantum computing system and calculate the energy levels of the subsystem and then aggregate them in a classical space again. So VQE, if we take VQE as an example, it's already a hybrid loop, but then if you put a more classical loop around it, which deals with fragments, then it becomes a really HPC and QC warranting approach there. Now, it's not straightforward to just add up the energy levels of the systems from the fragmentation. So there is going to be naturally a chemical or a chemistry validation of the aggregation and fragmentation system. But that's where the classical part comes in as well. And we are also looking at AI-related applications from the perspective of developing AI-defined quantum programs for automatic synthesis, for example, of hardware designs and software design, particularly, for example, in the areas of wireless communication, where training an AI model is better to be done on QC on HPC, because naturally we're not going to get the entire training data set into a quantum computing system. But then the parameter optimization or the parameter search is where it makes more benefit. So the use cases, we're increasingly looking for use cases where it warrants a hybrid workflow and not just a classical or a QC workflow. And all of this feeds into then, based on studying the use cases, we believe that we definitely are at the cusp of being able to define more complex algorithmic constructs and programming primitives. So we already have kind of efforts in the YAO framework in Julia, for example, where quantum computing friendly data types and operations are being packaged as libraries. And so we are looking at building more abstract programming constructs and libraries incrementally, and also domain-specific application libraries. So this is very apparent in the NISQ project under Quantum Flagship coordinated by Atos, where we develop a suite of technical libraries or application programming libraries. And they, for example, that's one category of libraries that focused on chemical systems or molecular systems. That's one that focuses on optimization related problems. There's one that focuses on NLP. There's one that focuses on probabilistic safety assessment and rule-based systems. So there are going to be different levels of abstraction of these algorithmic constructs that are built, and we are looking at that as well. The programming models, what the focus there is going to be, it's on basically looking at the classical HPC programming models like the MPI or OMPs, the primitive-driven ones, and looking at how we can have routines or directives that can demarcate or label basically a kernel needs to be offloaded or can be offloaded into a quantum computing system. And then what we eventually will have is something like we had in classical world, where we might have different implementations of the same kernel, and at runtime the runtime might actually decide based on the computer and data characteristics whether a kernel is suited to be offloaded onto a classical system or a quantum system. So extension of programming models is something that we're definitely looking at going forward. Third is compilation and verification of circuits as well at runtime. And then all of this would need a more system software support, which is also strongly coupled. So the dynamic mapping of these kind of hybrid workflows has to be addressed in the runtime of these programming models as well. So we are actually looking at how LLVM, for example, the intermediate representations in LLVM can be extended to accommodate translation to circuits that are, for example, specified in OpenQASM format and others. Naturally, there are already efforts that have been initiated in this domain. So EXAC and I think Microsoft had also integrated their QSharp framework to be able to leverage the intermediate language in LLVM. So going forward, we are actually looking into how LLVM MAR extensions can be formally specified to allow translation and optimization of OpenQASM quantum circuits within the classical compiler library as well. And performance measurement is something that's very unknown to us as well, because we have a good understanding of the metrics and the mechanism of measurement of performance metrics in the classical systems. It'd be at a compute level, at a network or a bus level, or an I/O level, or a storage level. We understand what the metrics are likely to be and how to measure them both at a hardware and software level. But when it comes to the quantum computing systems performance, it's still very early stages, rightly so. But we want to have a foresight as to what kind of metrics would we be looking at and how they can be collected through a software-enabled mechanism, and more importantly, how the performance metrics are going to be added to the performance reporting mechanism that we have in a classical HPC system. So how performance reports and performance analysis can be done in a more streamlined way when it comes to hybrid systems. So that's again a part of the research that we target doing. And as I mentioned, at a hardware level, it's different levels of integration there. And the top-down, it's a co-defined approach that specifies the requirements of each of these layers, and bottom-up, it's going to be the demonstrations of the systems as we build them incrementally. And naturally, all of this feeds into the skills development, and it's heavily research-driven program here. So I am aware probably I have just 4 more minutes. So what I might actually briefly touch upon is something called a quantum programming certification course. I'm afraid I probably will not have enough time to present the details of it, but this is something that iCheck has been working with the National Skills Development Agency and a Scientific and Industry Advisory Board at a national level over the last 18 months. It's been in consultation and development. So what this is not is actually, it's not a PhD program or a master's program. We leave the experts to actually develop the scientists and the academic community for that. What this is actually is to bridge the gap between someone that has a purely physics and mathematical skills to look at quantum computing and programming, and similarly someone from a classical ICT background who wants to kind of incrementally or increasingly get into quantum computing and programming. So it's supposed to be a bridging course that introduces the learners in an iterative fashion to come on board and build their math and physics and quantum mechanics fundamentals, and then start looking at the algorithmics and programming and application areas. So this is something that we are building at a national level, but we're very keen actually to work with the rest of the efforts around Europe and our partners as well to bring this to a European level through different channels that we already have in EuroCC through PRAISE training programs and going forward. So we'll be happy to actually leverage all of both of these, the certification course and the HiQuire initiative to formally start more concrete engagements at a national and member state level going forward. So with that, I'll probably finish for now, and I hope in the next opportunity we'll be able to share more scientific outcomes of the work that we are doing at a national level. Thank you.
Thank you, Venkatesh. Very interesting. Is there any question for Venkatesh? We have a couple of minutes. Let's wait if somebody has some question, or if not, maybe I can. Okay, and just a curiosity, Venkatesh, the last program that you mentioned is something that I didn't understand. Is something that you do after your PhD? You have to be. What is the level of the?
We have it's an entirely customizable program. People can choose different pathways depending on what their learning outcomes are meant to be. So on one extreme, it can be for technical managers in different organizations so that they can have an outline of the ability to track technology development and its application. On the other end of the spectrum are going to be developers and scientists and engineers who want to actually get into the algorithmics development and application development. So it's a a la carte, so to say, of modules, and we expect people to take different trajectories in the learning path. And we expect people to take it before their PhD or leading to their PhD as a bridging course, so to say.
Very interesting. Thanks for sharing. Okay. If there is not no any question, I think that we can move to the next speaker.